today we are going to learn chapter 10, 10.1. This is the last chapter. Yay! You made it. Congratulations. Okay, so chapter 10, it's about the two sample inference. So we have three sections. I don't do summary, right? Okay, so first one, proportions, and second one, two means matched pair samples, and then two means independent samples for section 10.3. Yeah, so we have two samples, right? So population one, population two, we collect the sample data from each population. Then we're using hypothesis testing and confidence interval. So basically, we're using two samples with combined chapter 8 and chapter 9. Chapter 8 about the hypothesis test and chapter 9 about the confidence interval, right? Okay, so 10.1, we have inference for two proportions. All right, so we know what is inference statistic, right? So we've been learn about the inference statistic. So inference statistic is we cannot survey a whole entire group. That's a population. That's what we do. We're gathering sample and then we guessing, we conclude about the population, right? So here, same inference for two populations. So we are using data from two samples to make a conclusion, which is inference about two populations. So about two populations, about two populations, okay, two population for what? Is it difference or about the same? Yeah, this is what we want to know about that. Okay. All right. Sorry. uh, yeah. So what we did earlier, right? Okay. Let's take a look. So we have a population one, population two, and then we get the random sample. And then we get another random sample from population two, right? So we are using piece of one. So piece of one about, we called true population proportion. Yeah, true population proportion. And so one is the sample size from population one. X of one, the number of successes from the population one, right? And the P has sub one, right? P has sub one, it's about population one, right? So X sub one over N sub one, right? So we have from population two is the same as everything from the population one. We do indicate two, P sub two, N sub two, X sub two, P has sub two, right? All right. Okay, so we do hypothesis testing, two proportion. So exactly same process with one proportion, but then we check the two proportion, right? Okay, so that is the same. All right, now, okay, how do we set it up? Hypothesis test with the two proportion, right? So we have, normally we have a P equal to some number, right? If we had one proportion, right? Okay, then we have two proportions, so one and two, right? So we indicate the piece of one equal to piece of two. So we had the null hypothesis test, no change, no effect, right? So we say the equal, right? So same as here, piece of one equal to piece of two, no change, no effect, right? All right, then this one we can express as other side is zero, So other side is 0. That means we can express like that, right? And then we say that this is a difference to 0. Difference to 0. All right, now we have alternative hypothesis test. So normally we are using inequality less than or greater than or not equal to, right? Same as here with the two proportions less than, greater than, not equal to, yeah? So once again, if we are using 0, other side, how do we make? Subtract difference, right? Less than 0 and greater than 0 and not equal to 0, yeah? So this is same as this equivalent the inequality, yeah? All right, so let's take a look. Oh, we have a p hat. So look, this is a p hat. And then look, we combined, right? Combined the x sub 1, x sub 2. We combined their sample size x n sub 1 plus n sub 2, right? So we could combined sample proportion or pooled sample proportion, all right? Yeah, pooled estimate. So let me write down. No, here we go. Um, pooled estimate, or we say the combined sample proportion. Yeah, okay. And then some textbook using the sub p has sub c using the first letter combined c. Yeah. Okay, so let us do this one. Example 1, we want to finding pooled estimate. So suppose a sample of 120 high school graduate has 51 that subscribe to cable TV service, and sample 160 college graduates has 70 that subscribe to cable TV. Find sample proportion for each population and the pooled sample proportion, right? Okay, so we have p hat equal to x sub 1 plus x sub 2 over n sub 1 plus n sub 2, right? Okay, so if we say that this is n sub 1 and this is x sub 1, right? It's hard to say? Okay, hold on 1 second. N sub 1, x sub 1, right? And then this is n sub 2, x sub 2, right? All right, so that will be x sub 1, which is 51, plus x sub 2, which is 70, over n sub 1, which is 120, oops, plus n sub 2, which is 160, right? Now, your turn. Can you please calculate? Oh, no, sorry about that. Find the sample proportion for each population, right? Yeah, then pull the sample proportion. Okay, so I just using the pooled estimate. It's okay, we can do the separately too. All right, so there will be, it's a 0.4321. Okay, then what do you get? The first one, P sub 1? P has sub 1, right? So that would be x sub 1 over n sub 1, so 51 over 120. 0.425, good. P hat sub 2, x sub 2 over n sub 2. So 70 over 160, what do you get? 0.4375, yeah? Excellent. Okay. So there is nice table, right? That's why I brought this one here. Okay. Now, interpret. So we have let me see. The first one, high school, right? High school graduate. They has a 42.5% high school graduate subscribe to cable, while the 43.75% of college graduate subscribe to cable TV, right? These numbers do not appear to be very different. Yeah, so very tiny, right? Tiny difference, right? Then we have assuming the proportion are the same for both population, then the best estimate for proportions of either population is the pooled estimate that about. So that is a 43.21, right there. So 43.2%, yeah. So this means if we treat all total there 280 people as one big sample, then about 43.2% of subscribe to cable TV. Make sense? Okay. Why we are doing this one? Because let's take a look. So the p hat sub 1, we have sample size is 120. P hat sub 2, we get the 160 sample size. So sample size is small, then we get the proportion. It could be by random chance, right? So we make a combine, then we get the more sample size, right? So it's like this. We flip the coin 10 times, and then we're getting head 60%. It's a high, right? Because normally it's we expected 50%, right? Okay, 60, it could be 60%, right? So that means maybe by luck, by random chance. But then what if we have 1,000 times we have an experiment, but we still get the 60%, right? Then that's not the random chance, right? So that's a real proportion, right? Okay, so that's here. So that's what we combined. Combine the pooled estimate, combine the sample proportion. So this one helps us calculate and test whether the small difference could just be random. Yeah. All right. So let us take a look this one. Let me arrange this note. All right, so let's talk about the symbol, right? Inequality symbol. We did earlier, right? But then we have less than, so smaller. The proportion is one smaller than others, right? So smaller, less than, and then same here too, right? And then proportion one is greater, which is larger, and then different, so different, not equal to, right? So we are using that. So they're using here too, right? Yeah. So same inequality, this inequality expression, or if we are using 0, it's the same, right? Okay, let us do this example 2. All right, so parents, how important it was that their children's school teaches them to develop social and emotional skills. Parents were asked to select from several options, one of which was extremely important. So from sample data, 28% of mothers and 20% of fathers selected extremely important. Okay, so number one, describe the population parameters. Okay, so let's talk about that. Yeah, so we are using population parameter, right? So we talk about the proportion, so piece of one, right? Piece of one. So that is population proportion, population proportion of mothers who selected extremely important. Okay, then we can notice the piece of two, right? So same, but it's fathers, right? So mothers, fathers, same thing. Yeah. Okay. Second part describes sample proportion. Sample proportion we had earlier from sample data, 28%, right? Of mothers, 20% of fathers. So P has of 1.28 and P has of 2 is 0.2 or 20. That's fine too. Okay, C. What are the hypothesis tests? So we had three types, right? Okay, so this one is higher, so we are using the larger for the alternative hypothesis test. So no, always the same. And alternative hypothesis test, higher, right? Or we can use that piece of 1 minus piece of 2 equal to 0. Piece of 1 minus piece of 2 is greater than 0, right? Okay. Now, assuming the result is to reject the null hypothesis test, state the conclusion in context. So we do reject the null hypothesis test means there is sufficient evidence to support the alternative hypothesis test, right? So we conclude the alternative hypothesis test. So that is true, right? Okay, let me bring this answer here. All right, so I brought the conclusion here. So if we reject the null hypothesis test, then there is a sufficient evidence to support the alternative hypothesis test, right? So in that case, the piece of one, their difference is greater than 0. How about that, right? So meaning, yeah, same as this one, right? This is the same. In context, there is enough evidence to show the proportion. So we just read their sentence, yeah, in the question sentence, yeah. So that proportion was a piece of one. That's the proportion of mothers who feel that it's extremely important that their children's school teaches them to develop social and emotional skills is greater. It's greater than the fathers. Yeah, we read their sentence. Make sense? Okay, so in general, we just remember what's the reject, the null hypothesis test means, right? So there is a sufficient evidence to support the alternative hypothesis test, right? Okay, very good. All right, so we have, they say that several conditions, we have to check that, right? So we did earlier, and what is n sub 1, n sub 2, and then samples selected from each population are independent, right? So this um, means that sample cannot overlap, right? So how do we check that whether independent or not? That sample size must be n sub 1 and n sub 2 less than 0.05 from the population size and 0.05 the population number 2, right? Yeah, because we have two different population groups, right? Okay. Some other book make a 10%. Yeah, but this textbook make a 5%. So we follow this textbook, right? Yeah, independent means the first outcome does not affect the second outcome. So in that case, a sample, right? So they are totally different, right? So they're not related to each other, right? Okay, now third one. Talk about the binomial experiment because we are using X, which is number of successes, right? Yeah, so binomial experiment criteria say that it must be fixed number trial and two outcomes, success or and failure, right? And then the probability come from the probability, oh no, probability come from the probability come from the success, yeah. And then independent, yeah. So we talk about the independent earlier too, right? And then we have to check whether the distribution, the distribution is normal, right? Why? Because we have to use normal distribution, the software, right? To find the probability, right? Yeah. And z-score too, right? The special z-score. Yeah. Okay. So then the sample size is big enough, right? So how much is the big enough, right? So algebraically we check that n times p times 1 minus p must be greater than or equal to 10, right? So in that case, we have two sample, two sample proportion, right? So we have the n sub 1, p hat sub 1, 1 minus p hat sub 1 must be greater than or equal to 10, and then the second one too, right? Yeah. All right, so we have all the summary, right? So this one. Okay, so how about this one? Alpha, same alpha, right? And then we talk about this one. And test statistic, z-test statistic, z, right? Yeah. So we are using two sample proportion. So they're using p has sub 1 minus p has sub 2 there. And then normally denominator has a p 1 minus p over n, right? But then using 2, right? Yeah. So n sub 1, n sub 2, but they're using only one p in the case, p hat. So yeah, p hat. Normally this one is what was it? P hat minus p, right? Yeah. But using p hat sub 1 minus p hat sub 2. All right. Then left tail test, same. So we're using this one for left tail test. Right tail test, we're using for this one right tail test. And two tail test, So here is 2 tail test. So not equal to different, right? Okay. Let us do these questions. So conduct hypothesis test. So this is a left tail test. Alpha is given 0.05. And then everything is given n sub 1, sample size 140, x sub 1 is 35 successes. And they don't say anything about the question. They just give us a number, right? Okay. Calculate sample proportion. We did earlier, right? So you can do that. Pull the sample proportion. Oh, then follow the steps to conduct hypothesis test. Okay, so we have to follow that, right? All right, so there. Oh, earlier one. Okay, let me bring here. All right, so the sample proportion, right? So sample proportion P has sub 1, so x sub 1 over n sub 1. So we have a 35 over 140. What's the number? 0.25, good. What about the P has sub 2, so n x sub 2 over n sub 2. So we have a 44. You are recording? Okay, good. So over 110.4, good. So what is the combined pooled estimate? Combined sample proportion, right? So just a p hat, right? So let's using that combined pooled. So x sub 1 plus x sub 2 over n sub 1 plus n sub 2, right? So I don't want you to get confused with just a p hat by itself, right? Yeah. But in that case, yes, we know that we are using two sample proportion, right? Yeah. Okay, so we have a 35 plus 44 over 140 plus 110. So 0.316. Yeah, good. Now, step one, we need to determine left tail or right tail or two tail, right? So this one, right? So we have that. Oops. Hold on one second. Hold on one second. So that copy. Ooh, too much, yeah. So it's a left tail. Ooh, come on. So it's a left tail test, right? So left tail test. What about the alpha level of significance, right? So 0.05, good. All right. Now we need to check whether normal or not. So let's check that, right? So n sub 1, p hat sub 1, 1 minus p hat sub 1. So n sub 1, which is 140, p hat sub 1, which is 0.25, 1 minus 0.25. What do we have? So we get 26.25 greater than or equal to 10. Good. What about second one? So P n sub 2, 110, and P P has sub 2.4. 1 minus P has sub 2, so 0.4, right? So calculate 26.4. Okay, good. So greater than or equal to 10. So we can conclude this is normal, right? Now we can use the software normal distribution, right? In the StatCrunch. All right. Z-tested statistic, I want to mention that there is a p-hat. That p-hat is It's not just a sample proportion, it's a pooled estimate. Pooled sample proportion means the combined proportion, right? So I want to make it like that so that you don't confuse, right? Okay. All right. So let us do this one. Z-test statistic. Z-test. So P has of 1. I am using here 0.25 there. And P has of 2.4 up there. Over inside the square root, the pooled combined. What's combined? Combined is 0.316. 0.316. 1 minus combined 0.316. And then 1 over n sub 1. N sub 1, I can see 140 plus over n sub 2, which is 110, right? Yeah. Yeah, can you please calculate? A little bit complicated, right? So using decimals, right? All right. So we get negative 2.5323. Yeah. All right, so left tail test, the z-score is very left, right? So we can guess, right? Yeah. So find the value. So we are using standard normal calculator, right? Yeah. So means that z equal to negative 2.5323 and the mean equal to 0, standard deviation is 1, right? Now what's the p-value? It's the left tail. It's a 0.005665, yeah? All right. Then how can you conclude? Even z-score, we can tell that it's very tiny, right? Unusual, right? Yeah, this is also unusual, right? Yeah. All right, then we do reject. Yeah, reject the null hypothesis test, right? Yeah. P equal to 0.0056. And then 4 decimal, then I can round, right? Less than alpha equal to 0.05, right? So we do reject the null hypothesis test. Let me denote it like that. That is, there is sufficient evidence to support the alternative hypothesis test. That means the left tail earlier, right? So left tail, this one. Let me copy. And here, we support that, right? Oh, yeah. So that is, yeah. We support this one, right? Okay, so that means, this means P sub 1 less than P sub 2, right? So that is the population proportion 1 is lower than, so that is population proportion 1 is lower than the population proportion number 2, right? Yeah. All right, so I'm gonna show you how to use StatCrunch, right? So everything. If we have this kind of a problem, we want to check the p-value, z-test statistic, right? So let's do it. Share. Oh, then I have to turn off here, right? PDF number one, huh? Okay, can you see? Where's everything? All right, so what we are doing, stack runs, right? So go to stack runs, we have a lot of things on there. All right, so go to stack, proportion stacks, and we are using two sample this time with summary. Yeah, okay. So we have, ooh. All right, so I'm looking at the table, I mean the pencil. I can make annotating. Huh. All right, so I can see that. All right, so stack, proportion stacks, two samples with a summary. Click that. All right. Number of successes for the first sample. So I took a picture over here. 35 for the successes for the first one. And the answer one 140. And sample two 44. And 110. And hypothesis test. What was it? Left tail, right? So bad on. Yeah, left tail. Okay, so critical value? Sure. All right, compute. Okay, so we can see that here z-test statistic. Oh, yeah. Critical value, yeah. Never mind about the critical value. Let me do it one more time. I don't want you to get confused. So let's do the calculate the proportion stacks to sample with a summary. Oh, I have to do again. Ah, sorry about that. 35. Yeah. And then 140 and 44 and 110 and left tail, right? Left tail. The compute. Yeah. Okay, so we have a z-test statistic and then p-value. That's how we get that, right? All right. Good. All right, so let's do this example. Example 5, two sample proportions. Okay. The Pew Research collected data from 279 low-income individuals, less than 30,000 annual income. Of these, 150 had broadband internet access in their home, and 410 individuals with a higher income, 100,000 or more annual income. Of these, 381 had broadband internet access in their home. Okay, so we want to test whether the proportion of individual with broadband internet access at home is lower for low-income individual than it is for those with a higher income. Use significance level 0.05, right? So let us do this. Okay, so the first one, we want to know about what's the p hat sub 1? So x sub 1 over n sub 1. So in that case, this is n sub 1, right? This is x sub 1, right? So that will be 159 over 279. Please calculate. Okay, 0.5699. How about p sub hat 2? P sub hat 2. So x sub 2 over n sub 2. So that will be that's n sub 2, x sub 2, right? So we have a 381 over 410. What do you get? 0.9293, right? So combined one. So we get x sub 1 plus x sub 2 over n sub 1 plus n sub 2. So that will be 159 plus a 381 over 279 plus a 410. What do you get? 0.7837, right? So let's check that. Let's check the step 1. Okay, so what do you think? So we test whether the proportion of individual with a broadband internet access at home is lower for low income, so than others, right? Higher income. So that will be the left tail test, right? So the null hypothesis test p sub 1 equal to p sub 2, and alternative hypothesis test will be p sub 1 less than p sub 2, right? Okay, the alpha, what do you get? 0.05, good. All right, now let's check the whether normal. So sample size, right? So we get n sub 1, p sub 1, 1 minus p hat sub 1 equal to, so let's see. I cannot see. Yeah, let me take a picture because I cannot see. All right, so n sub 1, we have 279. P hat sub 1, which is 0.5699. 1 minus 0.5699. What do you get? So we have a 68.4, which is greater than or equal to 10. So second one. So n sub 2, we have a 410. P has sub 2.9293. 1 minus 0.9293. Okay, what do we have? 26.9. Okay, then it's a normal, right? So normal distribution. All right, so we are using StatCrunch to find out the p-value with the z-test statistic, right? So we're following same as earlier, right? So we're going to proportion stack two samples, and they have z-test statistic. Wow, so low, negative 11. Oh my gosh, right? P-value, let's take a look, 0.0001, right? So then we do reject the null hypothesis test, right? And there is sufficient evidence to support alternative hypothesis test. In that case, the lower income broadband is lower than the higher income, something like that, right? So let me write it out. I need their statement here. Okay, test whether the proportion of individual with a broadband internet access at home is lower for low income individual than it's for those with a high income, right? Okay, so I'm using that statement to conclude, right? So p-value is 0.0001, I think, right? Yeah, it's less than alpha, which is 0.05, right? So we do reject the null hypothesis test since there is sufficient evidence. So sufficient evidence means enough sample evidence, right? Enough sample evidence. Since there is something to support that the proportion of lower income individuals with broadband internet access at home is lower than the proportion then the proportion of higher income individuals with broadband. Oof. Internet access at home. Yeah. Okay, very good. All right, so we talked earlier about two proportions of hypothesis test, right? This time we are going to talk about confidence interval. So we said the difference between two proportions because everything is a difference, right? Because we make other side is 0. So p sub 1 equal to p sub 2 in the null hypothesis test. So we making difference is 0, right? So p sub 1 minus p sub 2 equal to 0. Then alternative hypothesis test, we have lower, greater, or difference, right? Okay. Then we can express as a difference too, right? All right, then here, let's take a look. So we have, I want to highlight this one, p sub 1 minus p sub 2, which is approximately with sample proportion, right? So difference between p hat sub 1, p hat sub 2, which is in the case negative 3594, right? So what this means? This means we have a negative, right? So the percentage of lower income individual with broadband at home is about 35.9 lower. So we have a negative, so that is lower. Then in other words, if we have a positive, then that's higher, right? Yeah. Then the percentage of higher income individual with broadband at home. Yeah. If we say the other way, right? So if we talk about as a percentage of higher income, then we can say that 30.5% higher than, right? Yeah. So in other words, right? Yeah. Make sense? Yeah. We could say it this way. We can say this way too, right? So if we say that the percent of higher income individual with a broadband internet access is higher than percent of individual. Yeah. Make sense? Yeah. You know what I'm saying, right? Okay. Now we know that P hat point estimate for P, right? So we can say that the difference of P hat sub 1 and P hat sub 2 also point estimate for difference with P sub 1 and P sub 2, right? Yeah. Let's take a look here. So confidence interval, very similar. Yeah. We're using a little bit different formula because we are dealing with two proportions. Yeah. Yeah. So we have a sample size, n sub 1, n sub 2, p hat sub 1, p hat sub 2, right? Okay, so point estimate, we're using difference of two sample proportion about, right, of p sub 1 minus p sub 2, right? So we point estimate the p hat sub 1, difference of p hat sub 1 and p hat sub 2 of p sub 1, p sub 2. Makes sense? Difference of, we can see the difference, right? Yeah. All right, so verify normal, we did earlier, right? And then test, what was it? It was a test test statistic, right? This one critical value, Z critical value, right? So I made a mistake earlier with the sequence, right? So don't get confused. This is what did I say? Critical value. Z critical value. Yeah. All right, then we have a margin of error. Margin of error is Z critical value times standard error, right? Standard error in the case like that. Can you see that? A little bit complicated. Normally we have a standard error is square root. We are using p hat, so p hat 1 minus p hat over n, right? But since we have a 2, we add 2 of standard error inside the square root. Yeah? Yeah. Sounds like. Yeah. Not the outside. Yeah? You know what I'm talking about, right? Okay, now we have a lower limit, upper limit. Oh, then normally lower limit, we have a p hat minus, plus minus e, right? Margin of error. But then look, it's a difference between sample proportion, right? And plus minus margin of error. Yeah. Okay. Once again, the critical value we have when 99% the Z critical value is 2.576, 95% 1.96, 90% is 1.645. There is more, but that is a common one, right? So we are using common one. Okay, so let us do this question again for the confidence interval. Yeah? All right, so let's find out point estimate. Yeah, so point estimate, even though we have there, let's find out point estimate. The point estimate, we have P has a 1 minus P has a 2. So we have P has a 1, which is 0.5699 minus 0.9293. So it's a negative 0.3 594. Yeah. So we talked earlier. Step 2. Okay, step 2, what we have to talk. Oh. Verify the normal. Yeah. So we did that, right? Okay, so maybe we can this one, right? All right. And step 3, not tell, Z critical value. So when alpha equal to, no, 95%, that's better, right? No, 95%. So we had 95% is a 1.96, correct? Yeah, 1.96. So Z square is 1.96. Actually, critical value. And then step 4, marginal error. So marginal error, Z critical value times standard error. But in that case, standard error is special square root p hat 1 minus p hat over n, right? We had that, right? But then we add 2. So 1, 1, 1 plus 2, 2, 2, right? Make sense? Okay. So that will be 1.96. Do I have information? Yeah, information there. So perhaps the 1.5699, 1 minus 0.5699 over n sub 1, which is 279, and p has a 2.9293, 1 minus 0.9293 over n sub 2 for 10. Please calculate. A lot of work. Yeah, it's a 0.06317. Yeah. Okay, so step 5. Marginal way, I'm sorry, the lower limit will be p has a 1, the difference of 2 proportion, right? Simple proportion minus e, right? So that will be, we had earlier, negative, this one? Negative 0.3594 minus 0.06317. What do you get? negative 0.422. I want to bring up so that I can write down. 57. Okay. How about upper limit? Same thing with the addition with the margin of error, right? So negative 0.3594 plus 0.06317. So it's a negative 0.29423, right? Okay. Interpretation. So we had conclusion. Let me bring conclusion here. Yeah. Because I don't want to writing out. Okay, so we have a conclusion. We are 95% confident the proportion of a low income individual with broadband internet access in their home is between we are reading this one, right? So 0.29423, which is 29.4% and 42.3%, right? So until here, same as one proportion, same as interpretation of one proportion, right? But then we have a lower than, so from low income individual with broadband internet access in their home point of view is lower because we get the negative earlier, right? Remember? In the beginning, right? So we use lower than the proportion of a higher income. So if we say the higher income first, then there will be higher. Make sense to you? So we talked earlier, right? Yeah. So lower since the we had p hat sub 1 minus p hat sub 2 equal to negative 0.3594. Yeah? Lower the negative, right? Yeah? Okay. Let me show you StatCrunch, how to do it. All right, so let me make a share. But then this is exactly the same as what we did, right? Earlier, hypothesis test. So this is the same as instead of hypothesis test, we click the confidence interval. So let's do it. So proportion stacks, two samples with summary, right? Same as earlier. Stack, proportion stacks, two sample with summary. Okay, click that. Oh, do again. Let me see. Number of successes 159 and number of observation 279, and then number of successes for second one 381, and number of observation for 10. And then instead of a hypothesis test, we had a hypothesis test earlier, right? So we click confidence interval, right? Okay. Yeah, so now level of confidence is 95, and then critical value I can show you, right? Critical value, compute. All right, so that is the critical value 1.96, right? When the 95% confidence interval, right? Okay, now confidence level. Hold on 1 second. And this is the lower limit. upper limit when you did the lower limit, upper limit, yeah, same, yeah. Right? So by hand we get the same too, right? Okay. So critical Z. Uh Maybe can we check the margin of error by without hand without hand with by using stack crunch stack crunch. Okay, so margin of error. Okay, let's check that, right? So let's check the margin of error. It's Z critical value and then standard error, right? Okay, Z critical value, which is 1.96. Standard error is, let me calculate. So 1.9599, 4 times. Standard error 0.03223. So do we get the margin of error earlier? 0.0631. Okay, very good. So I get the same. So standard error, we're using this one here. And then critical value here. Then we get the same answer. 0.032231. Then same as earlier, 0.063169. Yeah. So there is one way you can do it, margin of error. Yeah. But you have to have all the information, right? Yeah. So, but still calculation, you have to do it, but less than by hand, right? Yeah. So just using the accurate information there, critical value times standard error. Make sense to you? Okay, very good. Any question? Good job. Okay, so I want to leave this one as your exercise. So can you please try? Then we are done for this section. So I will see you in the next section. Thank you so much. Thank you very much for watching. See you next time. Bye.